So in this lesson, we'll look at placement groups. From time to time, when we create our instances, we may need to put them on a certain availability zone in order to improve performance, or to guarantee high availability, or even to protect ourselves from failure. And so this type of policy can be defined in placement groups. Either you place your machines, or you place the machines automatically in predefined zones, or automatically in a random fashion. And so when you create an instance, you have to specify one of the following three strategies. The first one is the cluster strategy. In this strategy, the instances are grouped in a low latency configuration on a single overlay zone, which guarantees high performance but also exposed to high risks. The second strategy, the spread strategy, consists of spreading our AC2s over different hardware and with a limit of 7 instances per availability zone for each placement group. This corresponds well to critical application, for example. The first strategy is a partition strategy, which is similar to propagation. However, the instances are distributed over partitions which are themselves distributed over different hardware within the same availability zone. This ensures high performance and very low risk. Finally, this type of placement group can include up to 100 instances. This corresponds to large applications such as Cassandra, Kafka, or Hadoop. Let's take a closer look at the cluster placement group. Here we have our cluster placement group with our 6 AC2s. Remember that we can have up to 7 per zone. So we have our 6th instance on the same physical medium and on the same availability zone, which guarantees us low latency and very fast network traffic. The advantage is that the network is efficient between the instances. The disadvantages are that if the physical medium fails, all instances fail at the same time, in which case should you select this option. It can be used in big data for processing requiring fast execution and weekly jobs, for example, or application requiring low latency networks. Now let's look at spread groups. The spread placement group is the opposite of the cluster placement group because here what we want is to avoid that our machine can fail at the same time. So what we're going to do is we're going to put each of our AC2 instances on its own physical media in a given availability zone, which guarantees that if my machine 1 here, AC2 goes down, machine 2 will continue to work. If the all availability zone has a problem and stops working, I will have my application running on 2 other availability zones. What does this mean? What advantage does it have? We can spread our AC2s over several AZs, that is to say, availability zones. This reduces the risk of simultaneous failures. Our AC2 instances are on different physical media. The disadvantage is that we have a limit of 7 instances per availability zone. What are the use cases for this type of placement group? Application requiring very high availability and critical applications where each instance may be isolated from the failure of the others. Now let's look at partitionated placement group. We are in the availability zone. We have our first partition with 4 AC2 instances, a second partition with 4 other AC2 instances. Remember that we can go up to 100 instances per partition, and the third partition with likewise 4 AC2 instances. This solution allows us up to 7 partitions and up to 100 instances per partition. The instance of a partition does not share the same physical media as the others. Finally, the failure of a partition can affect many instances, but will not affect the other partitions. To have access to the information regarding each partition, AWS metadata has to be used. What are the use cases? For HDFS, which are very resources-intensive applications, like HBase, Cassandra, or Kafka. Let's see how to create placement groups in the AWS AC2 console. We'll go to Network and Security, Placement Group, and create our placement group, which we'll name High Availability. Next, we'll create a second placement group, this time from our critical application. And here we'll choose the spread mode. Once created, we'll create a third group. My disrupted application. This time I'm going to put it in a partition, and in terms of the number of partitions, as you can see right here, we can go up to 7 partitions. We'll start as in the example in the lesson, that is to say with 3 partitions, and we'll create our placement group in partitions. You can see here on the placement group console that we have our 3 ability groups, the corresponding strategies, and the status, and there is the number of partitions where relevant. Now that we have created our group, we'll see how to assign them to an instance. Let's go to our AC2 console, we'll launch an instance. As usual, we use our standard T2 Micro Linux to AMI. Next, here in the options for creating your instance, you'll be able to choose the placement group. And by checking this little box, we'll be able to assign a placement group to our instance. We can either use an existing placement group or add a new one. What we'll do is use an existing investment group. We'll take the spread. You see you can only launch up to 7 more instances in this investment group. If I want to have the partition mode, I'll choose it here and I'll define the target partition in this drop-down menu where I'll choose an automatic spread if I want AWS to find the best solution to spread my instances. As you can see, there is no cluster mode here. This mode does not work for T2 instances, so what we're going to do is to go back to the choice of the instance and take a very large instance. An extra large M5A. So I'll do the following. Do I want to continue with this type of instance as it is a bit expensive? So I'll say yes for now. And so here I can choose my cluster placement group and I can create my instances in a placement group that guarantees them a very high availability. That's it. I'm not going to evaluate because I don't want to use a large M5A. However, this is how you assign placement groups to instances.